Colleagues, I'm just going to show you a brief tutorial as to how to use OLabs. It's an excellent resource material, an excellent tool for your online labs. So what you're going to do is you're going to go to your browser and type in OLabs and it should come up. I already have it saved here, so I'm going to just click it. I bookmarked it and it gives you by subject. So let's say I want to do a physics lab. There's a listing, so it shows you the lab per grade, so the different topics that the students are supposed to cover, and then you can just look for the lab that you want to do and select it. So I'm gonna start off with something simple because for my fourth form group I normally start them on measurement. So I'm gonna click on the vernier caliper because that's the lab I'm interested in. A beautiful thing about this app is that it gives you notes on the lab itself, so it provides a lot of resource materials for the students so that they can do independent reading on the topic. So it gives you the set of objectives there. You can take notes from this. It gives you the theory. So for this particular lab, the students will get the information as it relates to how to label the vernier caliper and how to use it and the different calculations that are associated with it. Next thing you do is just tap this tab here at the side with the lines, and it will show you different things. So if you want the procedure for the lab, you click it and it shows you the materials that you're going to need, and it gives you the procedure as if you were actually at school, and then it modifies it as it relates to the virtual lab that they're going to be doing. So if you're doing this lab virtually, then this is the procedure that the students will use. So they would have to follow this procedure step by step in order to do the simulation. It gives them the table, right? So that is what that is looking like. So now that the students are familiar with what is required as it relates to the step, etc. Say you want to show them a video of how to use it before they actually do the simulation, you have that option here. Just click on that, and a link to a YouTube page with the simulation as it relates to this particular lab simulation will come up here, and then you can just play the video. Right, so this one is taking a little bit of time to load. I guess my signal dropped a bit, so all you have to do is just press play and you're able to view it. So after watching the video now, the students will be ready to try out the simulation. So this is the instrument, right? These are the different objects that they can measure. All they would have to do is just click on it, and then just as if they were in the actual lab, they'll just slide the jaws together and then zoom here to take the reading on this scale, and then come over here and zoom here to take the reading on that scale. Once they do that, they are going to come here and click type in whatever value that they think the measurement is, and the system will check it and they'll know if they got it right or wrong. So the teacher can actually go in and assess them if it is that they're actually reading the instrument properly. And they have the option of inputting their information here as well for that same table that you see, and they can save it, they can print it. So it's a very good tool, right? And they can select what they want to measure, if it's a length, etc. So that's for physics. Now let's just go back and see what the other labs look like. Because you find sometimes it's easier to use the virtual labs, especially for the students. They'll understand the information better than just sending a YouTube video for them to watch it. So if you can find the simulations and have them do it, it's more meaningful for the students. It makes it easier for them to write up their labs. Alright, I'm gonna jump over to bio. And you can use this for both bio and integrated science because you have some labs that overlap. Alright, so you have different labs here. You can even use a scale to measure the balance, to measure different mass. If needs be, you have the option of using microscope to view what's there. Let me just look for one of the most simplest labs here and just look at what it is, what the template is for that lab. So this is a starch lab. It gives you the notes. So you can even click on these diagrams and copy them and paste them and add them to your Google Classroom, or just send the link if it's just the notes alone that you want the students to have access to. So you don't necessarily have to just use it for that either. You can use it for notes. Alright, so I'm just going to go down to simulator. Of course, you'd have to read the procedure to know exactly how to use it. So here I have different listing of food samples that I'm going to be testing for starch. You can select the test type for this particular lab. It's iodine test. So iodine is the solvent that you're using. See, I'm going to test the carrot for starch. It populates a test tube with carrot extract. Then it tells me what I need to do. So it says I'm supposed to drag the dropper and put it in the test tube, and then add the drops, then replace it, put it back in the iodine, and then I'm supposed to select whether or not starch is present. So based on the background knowledge, the student's supposed to know what the answer is. So let me see if this actually works. So I'm going to get some bread. I'm going to do the same thing. Okay, so when I put it on the bread, it turns blue black, so I know that starch is present. So I can click yes for bread. So this can actually be used because the students you can tell them to use the food items that are there. They can put it in table format, and then based on the results, you can ask the students to share their screen while they're doing the lab in in Google Classroom, so that you can validate the results that they have, so that they can put information in the table and see it actually. The tick came up a while ago to indicate whether or not whatever I did was right or wrong. So it can serve as a checkpoint for the students. So that's what the bio lab or the IntiScience lab is looking like. And lastly, let's just take a look at what the chemistry template is looking like. Alright, so you have several labs that you can do here as well. All different types of labs. I'm going to look for one of the simplest ones that doesn't require a lot of steps. The separation techniques. Let me look at that one. Alright, so you have different types of separation techniques, and all of those would be accessible in the lab. So you just choose whichever one you want to do. So you have chromatography, the list goes on, fractional distillation, centrifugation, all of those. So you choose one. Alright, so I'm going to go to simple distillation, and you can select your mixture. So you have water, acetone, pentane, heptane, toluene, and hexane. I'm going to work with the water and the acetone. Then it shows me the setup here, so the students know exactly what it is. If you should go back to the notes, etc., for the lab and the objectives and the procedure, it will give you a list all of the apparatuses and the materials that you're using, and give you background information on them and why they're used. It will also give you background information on the lab as it relates to what it is you should get and why you're getting that result, or why you're getting those results. Then you click on start. Once you click on start, the heating mantle at the bottom is heating up the round bottom flask. If you're realizing it's bubbling here, and then you're actually able to see that the temperature reading increased, as well as you're seeing that the setup is actually working. So the students can look at this and know exactly what it is that is supposed to be happening here. And once you press on the idea, which is for information, it gives you information about the lab. So yeah.